Okay, so it's time to start. Welcome everybody to our PLS 2022 conference, Prelude number 2 session. And yeah, it's our pleasure and honor to have Nicole and Sven here to introduce the combined use of partially square structural equation modeling, PLS-SEM, and the necessary condition analysis, Nca. Before we get a little bit into the topic, just 1 or 2 words. As you know, we planned to have another PLS conference in Beijing in May last year, but for the known instances, we had to postpone the conference. And the main conference will now take place at the end of October 2022. So there's a lot of time still ahead of us. And in order to entertain ourselves in between, we decided to schedule these Prelude sessions, and we started with Prelude session number 1 on predictive model assessment a while ago. And today we have Prelude session number 2, which is on PLS-SEM and Nca. And in October, at October 27 this year, we plan to go on with Prelude session number 3 before in April, May 22, the last and the 4th Prelude session will follow. Today, Nicole and Sven will address super interesting topic in PLS-SEM because it allows us to further substantiate the structural model and the structural model relationships. So what we are looking at is necessity thinking, and this is relevant because we have many situations where we come with a claim that A is a necessary condition for B, or B requires A, and the like. And the necessary condition analysis is a useful tool to further identify and support the necessary conditions. And therefore, it's highly suitable also for PLS-SEM, where we ask the same kind of question when it comes to our structural model and the hypothesized relationships. For this reason, it's super interesting to learn today from Nicole and Sven what Nca is and how to bring it into the PLS-SEM context. Before we get started, we switch to the next slide. I would like to introduce Nicole and Sven really quickly. And this is more like a Hamburg session, because we have all 3 of us have very strong links to Hamburg. And to start with Nicole, Nicole, she studied business administration at the University of Hamburg with, amongst others, a major in operations management, and started as a PhD student at the Institute of Operations Management at the University of Hamburg. And that's where I got to know Nicole. We were more or less sitting next door to each other when starting our university careers. Nicole received a PhD on the internationalization and firm performance from the University of Hamburg before she continued her academic career at Hamburg University of Technology. And that's where she received her habilitation. That's in Germany, something like a second PhD, which you need for the qualification as a full professor. And she accomplished this quite ambitious task, because this is on a much more elaborated level, on the determinants of success in international business. The research focus today is on strategic and international management with a special emphasis on cross-cultural aspects. And Nicole's publications have appeared in renowned journals such as the Journal of World Business, the Journal of International Management, International Business Review, International Journal of Human Resource Management, and Long Range Planning. Let's take a look at Sven. Sven is now a professor of human resource management and the head of the chair of labor human resource management at Helmut Schmidt University. That's the University of the Federal Armed Forces of Germany in Hamburg. And he studied sociology, psychology, and economic sciences at the Friedrich Schiller University in Jena. And for his doctorate, he came to Hamburg and joined the University of Hamburg, where he got his further qualifications, especially the habilitation, again, the second PhD to become a full professor in Germany. And his main research interests are in the interrelationships between the design of human resource management and its effects on employees and organizational performance. Most recently, Sven has worked on HRM systems, job qualification, job satisfaction, as well as on the influence on national institutions and culture. His research has been published in leading international journals such as the Human Resource Management Journal, Human Resource Management, International Journal of Human Resource Management, and Journal of International Management, as well as International Business Review. I will provide some links later in the chat so that you can directly inspect Sven's and Nicole's web pages for further information on our presenters today. But yeah, on behalf of the PLS2022 conference, to name Huwen Wang, Yi Liu, Marco Saarstedt, and myself, who are the conference co-hosts, it is our pleasure to welcome you, and we are quite excited to learn about Nca and PLS-SEM, and this is definitely going to become an enjoyable and an informative afternoon. So that about expectation management, and now the floor is all yours. Welcome, and yeah, please go ahead.
Okay, I will start. Thank you very much, Christian. Even though I have to admit, it was a really long introduction. It was really nice to hear it all. However, it cost us 5 minutes, I would say. We have a tough program, and so we have to go ahead. But fortunately, this session is recorded, so if I'm too quick, you can watch a video afterwards in slow motion, like something like that. Okay, I'm starting. With the first part, we kind of assume that you are familiar with PLS, and therefore our focus in this session is on introducing you to necessary condition analysis, to necessity thinking. So the first part is the emphasis on Nca. This first part, it depends a little bit on how many questions we will receive, is about 60 to 90 minutes, I would say. If you have any questions during the presentation, please put them in the chat. Nicole and Wangu Lee, who's also familiar with Nca, we will address your questions either in the chat or will direct these questions to me, and we will make a break during the presentation and to answer your questions. So I'm going to show you why Nca might be relevant for your study or in general. How you can conduct an Nca, and I will also give you an example to illustrate what Nca does. And afterwards, Nicole in the second part will show you how you can best combine your PLS-SEM analysis with Nca. At the end, if you are still with us and decide to apply Nca, we will also give you some information on support where you can find more information on Nca. And at the end, we will have a Q&A session where we will address all the questions that have not been answered during our presentation. So I'm going to start. Why Nca? First of all, some methodological publications. These publications are from Jan Dull, who we would call the father of Nca, because Jan, he invented basically the methodology. The first paper appeared 2016 in Organizational Research Methods, and it's kind of the core paper or the initial of necessary condition analysis. We have further paper on the statistical significance test that was later on implemented, and Jan recently also published a book on conducting necessary condition analysis, which is kind of a very comprehensive source on how to conduct the necessary condition analysis. In the last years, we saw a rapid increase of Nca-related publications. So if you consider that it's a really new methodology, it was established in 2016, at the end of 2016, but now we already have 80 publications using Nca. And You see here very different fields of research. However, if you look at these different numbers where the publications appear, I think there's a huge potential, and maybe you can also be a pioneer of using Nca in your field. Nca is currently also recommended from key people in methodology. For example, Hermann Aguinis, who's the upcoming president of the Academy of Management. He recently suggested to use Nca to address research challenges in international business research. And we think this is really a good sign that Nca really is an interesting topic and maybe does something that other methodologies don't. So what is Nca? Basically, we could say that Nca is an analytical approach and a data analysis technique to identify necessary conditions in data sets. The focus of Nca is on single conditions that are necessary or critical for the outcome. So applying Nca, you have statements in mind like you must have X to have Y, or you must have a certain level of X to have a certain level of Y. Yeah, or in other words, if you assume that X is necessary for Y, you assume that you will not have a Y if there is no X. Yeah, and if Y is present, there will always be an X present. Yeah. Necessary conditions are everywhere. So having an internet connection is necessary, but not sufficient for attending this webinar, right? Having a GMAT test score is necessary but not sufficient for admission to a PhD program. Many who applied for a PhD program worldwide might need to have a high GMAT score. And an example from management, I will provide you some more examples in a minute. Senior management commitment is necessary but not sufficient for successful organizational change. So in our everyday life, we use multiple words representing necessity logic. Yeah. X is necessary for Y, but we also say X is needed for Y, X is critical for Y, X is crucial, essential, indispensable for Y, X is a prerequisite of Y, requirement, and we can go on, okay? You see the table. Sometimes we also state a necessity in terms of constraints. So X constrains Y, X limits Y, X blocks Y, X bounds Y, restricts Y, is a barrier for Y, is a bottleneck for Y. Yeah, in all these instances, we say that without X, there cannot be Y. Yeah. We find necessity thinking or necessity logic in many, many theories. And also, if you have a look at different journals, maybe also in your field, you will find many theoretical statements on necessity or theoretical statements that use necessity logic. Here are just some examples from the Academy of Management journal. So, for example, researchers state that emotion recognition may be a necessary but insufficient ability involved in the performance of transformational leadership behavior. Or social relationships are necessary but not sufficient for promoting high performance cross-business unit collaboration. And a final example here, I will further use this example in a minute. Organizational commitment may be a necessary but insufficient condition for low absenteeism. I have more examples and I could go on. I will not read these as examples, but I will point you to a restatement here. Gary Gertz, he is one of the modern thinkers of necessity logic. He stated that for any research area, one can find important necessary conditions. And I believe personally he is right. And at the beginning, we saw that multiple research areas started to use Nca. And in multiple research areas, Nca is applied. And I'm sure if you have a look at the publications in your field, you will find expressions like X is necessary for Y. So necessary conditions in practice, necessary conditions are of high practical value. And from my perspective, this is a very, very good reason to study necessary conditions. Why have necessary conditions a high practical value? Yeah, simply because if a necessary condition is not in place, there is guaranteed failure. Yeah, the absence of a necessary condition cannot be compensated by other conditions or other determinants. So, or however, we could say the presence, or it's important to note that the presence of the necessary condition does not guarantee success, but it may increase the likelihood of success. Yeah. This high practical relevance of necessity thinking is also reflected in various concepts. Here's the Moscow method. Maybe some of you are familiar. So what does the Moscow method in project management says? The Moscow method distinguishes between the must-have factors, the should-have factors, the could-have factors, and the would-like-to-have factors. And which are the most important factors? The must-have factors. And practitioners are usually looking for the must-have factors. Not at all the other factors that can influence a desired outcome, but at the must-have factors that are necessary for the outcome. Yeah, and that is the key or the main focus of practitioners. Nca represents one of three causal paradigms. Yeah, we have additive logic. This is the logic we are most familiar with. Yeah, when we do research, we usually assume that single determinants are sufficient but not necessary for changing the outcome. Yeah, our theoretical statements are similar form like it is presented here. X likely has an effect on Y on average. Yeah, when you look at the hypothesis in every research field, you will find, or you already have used a similar hypothesis. You assume that X or a determinant is able to increase a desired outcome. Yeah, this is this additive logic is usually used in regression-based methodologies, and it's additive because each single determinant, yeah, can compensate for each other. Yeah, try to imagine the formula for the regression analysis, and you will see that each of the single determinants within the regression analysis, yeah, is able, or there is an additive logic in this formula. So every single determinant can compensate for the other. There's a second logic, which is configurational logic, which is used in QCA. In QCA, we search for combinations of single determinants, which are called configurations, that are sufficient but not necessary for producing the outcome. Yeah, the basic principle here is equifinality, and the theoretical statement usually is configuration of different determinants produces Y. Yeah? And we have necessity logic, which is used in Nca. In Nca, or applying Nca, we assume that single determinants are necessary but not sufficient to allow the outcome. And the theoretical statement here is there must be X to have Y. From our perspective, each causal logic needs the correct methodology. So for additive logic, as I said, we usually use regression-based methodology. For configurational logic, we use QCA. And for necessity logic, we would suggest to apply Nca. However, in the past, we have often observed a misfit when testing necessity, especially when necessity was analyzed with regression-based methodology. I wouldn't say that it is a mistake or an error that occurred in past research. It was simply a fact that no correct methodology was available. So here's what usually happened. Yeah, in many theories, we see necessity statement either in the introduction, in the theory, or hypothesis section. Yeah, here's an example from Hausknecht, Academy of Management. In the theoretical section, Hausknecht state that organizational commitment may be a necessary but not sufficient condition for low absenteeism. So in other words, the assumption is that you will if you want to have low absenteeism, you need to have organizational commitment, right? So that's the theoretical statement here. So, but what happens is the necessity statement somehow magically is reformulated as a traditional hypothesis with an unspecified positive association between cause and the outcome. Yeah, the example here is the hypothesis in Hausknecht et al. When organizational commitment is low, higher levels of absenteeism may occur. This is a completely different theoretical statement, yeah, than the previous one. The previous one was necessity logic. Now we have sufficiency logic. Organizational commitment can contribute to higher levels of absenteeism. And the next step, we see, or we saw in the past, a traditional association analysis. So Hausknecht, we applied regression analysis, and defining is that organizational commitment indeed can reduce absenteeism. So organizational commitment on average contributes to lower absenteeism. However, at the end, if the hypothesis was confirmed, so Hausknecht et al., we found a significant association in the discussion section. We said the findings show that high organizational commitment is necessary to avoid high levels of absenteeism. And I would say, no, it's not a correct logic, because the methodology that was applied cannot analyze for necessity. And therefore, this conclusion at the end is not fully correct. So why NCA? I would say because many phenomena include factors that are necessary conditions that can stop the outcome. So we have in many research fields, we have phenomena that might be necessary conditions. Second, I would say applying NCA, we can gain new theoretical insights, very interesting empirical insights, which help us to understand these phenomena and to help us better understand. Christian, he was mentioning it at the beginning. So combining NCA with another methodology like PLS helps us to better understand the structural model, helps us to better understand the relationships within this model. And last but not least, as I said, NCA has a high practical relevance because we are focusing on the must-have factors. If you want to further read something about the relevance of necessary conditions, here's a suggestion for further reading. If you're in the field of human resource management, you might be also interested in this study. We have a very nice example using high performance work practices and the ability, motivation, opportunity model, which basically includes necessity thinking, and we are applying this to HRM. Okay. That was already my first part, and I suppose we already have some questions.
That's true. We have a few questions that were coming in the chat, and maybe it's a good idea just to repeat one or two of the concepts that you just introduced to make that fully clear. Nonetheless, I mean, Sven will anyways introduce one more bigger example, so I guess the understanding will be deeper and deeper the more we progress. But there was one issue coming up on slide 10 where there was this overview of words that are used to express necessity or necessary conditions. And these were differentiated between enablers and constraints. And there was this question mark here, what actually is the difference now between an enabler and a constraint? Why are there these two different categories? What is this about?
Yeah, this is kind of the wording we are using. Yeah, so X is necessary for Y. We would say, okay, without it's kind of just where we tried or where we had a look at the different formulations we are sometimes implicitly are using to express necessity. Yeah, so sometimes we say, okay, if you have X, you will have Y, or you can have Y. Yeah, it's kind of enabler. And the other formulation would be, if you don't have X, you will not have Y. And what is kind of the basic distinguish or the basic difference here? Yeah, so in one sense, X can block the outcome and desired outcome, and the other formulation is kind of more thinking about, okay, I need to have X to have Y. Yeah.
And I think the usefulness of this table will become much clearer when you start with your own projects, because with necessity logic, you do not have a lot of well-established theories that already talk about this logic. So very often when you go through the articles, you find a lot of arguments that are necessity-like arguments. And you see very often that authors are using exactly these expressions to talk about necessity. And I think that can be useful later when you are in your own projects to identify, is there a necessity thinking in my field? What is it about? And for that purpose, I would say these expressions are quite useful. Sven, there was another aspect.
Well, maybe just something to add. I think it, when we have finished this session today, hopefully you are aware what we need to better distinguish between sufficiency and necessity logic. Yeah, sufficiency logic where we assume that an x can increase a y on average, and necessity logic where we assume that x can block y. Yeah, and sometimes, or if you look at your theories, researchers are usually not aware of these differences, and all these expressions are sometimes used implicitly, and it's not clear if you have sufficiency logic in mind, additive logic, or necessity logic. And therefore, it's important to also think about these expressions we are using. And from my personal perspective, we as researchers, we should be very careful with the words we are using. If you're making a theoretical statement, we should be sure that the theoretical statement really implies the correct relationship or the correct formulation between cause and outcome.
There was one more question. I'm not so sure if it has resolved already in the meantime. It is about when to use necessary condition analysis, and maybe the slide number 15 could be something that could be of help. And Sven, maybe you would like to repeat or give another idea on that to make this fully clear, when we should use NCA.
when you should, okay, I would say a lot more about when to use NCA. At the moment, my first reaction would be when you have a theoretical statement that implies necessity. If you have a problem in mind, yeah, that you want to resolve, and now you're thinking about a necessary relationship within that could resolve your problem, I think when you should start thinking about using NCA. So yeah, the simple answer would be if you have a relationship that is based on necessity, you should apply NCA. Yeah.
I think these were the two key issues. At least I don't see any more pressing issues in the chat, so feel free to go on.
Okay, thank you. Yeah, more pressing issues will come up when we go more into detail. So conducting an NCA, so how can you apply NCA? And as I just said, the first step in conducting NCA is to formulate the necessary condition hypothesis or necessary condition statement. Yeah, you need to explain why the absence of X guarantees the absence of Y, and why the absence of X cannot be compensated by other factors. So yeah, that's the starting point from my perspective. You need, if you're thinking about necessity and if you're thinking about using NCA, you need to start from theory. Yeah, and starting from theory implies thinking about these two issues. Yeah, and starting to think about the relationship between X and Y. Yeah, usually we have X and Y, and we put a plus or a minus, which indicates that on average we assume that X is changing, Y will increase or Y will decrease. Yeah, but with necessity thinking, we put an NC here, which indicates necessity. So we assume that X is necessary for Y. Necessity thinking or necessity theory is very parsimonious. Yeah. What I mean here is that necessity thinking is fundamentally bivariate analysis. Only two variables are analyzed at a time, one X and one Y. And this is possible because a necessary condition always operates in isolation from the rest of the causal structure. Yeah, think about a car. Yeah, a car needs an engine, whether it's powered by fuel or electricity, and the car needs wheels. Yeah. Both are necessary conditions that the car can drive, but both necessary conditions are independent from each other. So, and therefore, and I think that is also a very nice feature of necessity theory and necessity thinking, but it is very parsimonious. However, this doesn't imply that you cannot analyze multiple necessary conditions. On the contrary, in complex models like structure equation modeling, each independent variable, each exogenous construct can be a necessary condition. Yeah. However, when more variables are potential necessary conditions, the analysis for these conditions is done separately. And this is possible since the necessity of X1 on Y does not depend on the necessity of X2 on Y. We have
immediately one issue that is very quickly resolved. There's a question whether we would need to run a necessary condition analysis 3 times, for example, if we have 3 different necessary conditions to be tested?
If you have 3 necessary conditions, you just can use one command, and this one command makes the analysis for all the 3 necessary conditions. However, the analysis by itself is a bivariate analysis. So you do not you have to skip this thinking of like multiple regression analysis, where you include many variables in your analysis and also control variables. What is not necessary in NCA. I will also show you when I have the example. We do not have the problem of omitted variable bias, applying NCA, because as I said, the necessity of one determinant is independent of other determinants. Basic types of necessary conditions. I think this will also help to better explain the idea of necessity. We can distinguish between dichotomous, discrete, and continuous necessary conditions. Dichotomous is the easiest way to think about necessity. So we are thinking about a condition and an outcome, and the absence and the presence of the condition and the outcome. Think about my original statement about the internet connection. But you need to attend this webinar. So you need to have an internet connection. The internet connection needs to be present. Only with the internet connection, you will be able to attend this webinar. The internet connection is necessary, but not sufficient. So you will have cases here. The dots represent cases, or numbers, instances. Many people Many people have an internet connection. However, having an internet connection is not sufficient to attend this webinar. You might need to have information on the link to this webinar. So having an internet connection is necessary but not sufficient to attending this webinar. If you don't have an internet connection, you will not be able to attend this webinar. We can extend this idea to a more discrete case, so low, medium, high levels. And with the discrete case, we have more fine-grained analysis or more fine-grained statements. And we can also extend these to continuous necessary conditions, where we have here a scatter plot and we see an empty area in the upper left corner. And we see that X, the condition, you need to have a certain level of X to have a certain level of Y. And that is basically what NCA does. It searches for empty spaces, independent of the data structure. And each of these instances and these tables here, you see an empty space, and this empty space indicates necessity. We have combinations of dichotomous, discrete, continuous variables that are possible. We will not cover that. However, I will have a closer look at these 3 different types of necessary conditions. So here's the dichotomous case. In the dichotomous case, we formulate a necessary condition in kind. Necessary condition in kind. We just say that X is necessary for Y. We do not make any assumptions about the level of X or the level of Y. We just have a basic assumption about that X is necessary for Y. That was our initial example. That the presence of X is necessary for the presence of Y. However, we can also play with absence and presence of X and Y. For example, here, the absence of X is necessary for the presence of Y. So, for example, Christian, maybe he's hoping that coronavirus will not be present in October. So, because the absence of coronavirus will give him the opportunity to make an on-site conference. And so we have one example about the absence of X that could be necessary for the presence of Y. Another examples are just the presence of X is necessary for the presence of Y. The absence of X is necessary for the absence of Y. As I said, we can extend the dichotomous case to a discrete necessary conditions with levels or scores where we have more than 2 levels. So here we have 3 levels, and we can make more precise statements, and we call this necessity statements in degree. So we can say that a level of X might be necessary for a certain level of Y. Yeah, an example here, a medium level. Yeah, if we call this is low, medium, high, a medium level of X is necessary for a superior level of Y. So this is the highest level of Y is 2, and you need to have at least a medium level of X to have a superior level of Y. Here's another example where we have a high level of X is necessary for a superior level of Y. Yeah, if you do not, if you have a medium or a low level of X, you will not have a very high level of Y. Yeah, and so on. I think the basics or the logic should be clear now. And again, we can extend the discrete case to continuous necessary conditions, which is especially interesting also applying Nca when you have latent constructs. So here's the, these charts reflect the same pattern what I was using for the dichotomous case. So a high X is necessary for high Y, a low X is necessary for high Y, high X is necessary for low Y, and low X is necessary for low Y. And interesting, with continuous necessity statements, there are further options, in particular nonlinear relationships. So you could think about necessity in terms of a concave or convex relationship. You could also think about something like that, yeah, where medium level of X might be necessary for a high level of Y, yeah, in these two instances, or also theoretically possible a low or a high level of X might be necessary to achieve a high Y. As I said earlier, Nca looks for empty spaces, and this is done with the so-called ceiling line. The ceiling line is the key function in Nca. Yeah, you're all familiar with the regression line, which is the key function in regression analysis, and what regression line is for OLS and other methodology or related methodologies. The ceiling line is the key function in Nca. The ceiling line separates the space without observation from the space with observations, and it determines the level of the condition X that is necessary to reach a certain level of the outcome Y. In the software, there are multiple ceiling lines implemented currently. Two default ceiling lines are the CEFDH, which stands for Ceiling Envelopment Free Disposal Hall, which is basically a step function. And this step function is recommended for discrete data or when the pattern of the observations are near the border is irregular. And we have the CRFDH, the Ceiling Regression Free Disposal Hall, which kind of smooths the step function using an OLS regression line through the corners of the step function. And this is recommended for continuous data or when the pattern of observations near the border is approximately linear. So I think that helps to understand this. So you see a scatter plot, yeah, from a fictive data set. You have X and you have Y. And the blue dots are observations, and the ceiling envelopment line, yeah, uses the upper left or the extreme cases in the upper left corner, yeah, and distinguish the empty space from the space with observations, yeah. And the ceiling regression line is an OLS line through the ceiling envelopment line. Yeah. This chart also nicely highlights the difference again between Nca and OLS or regression analysis. The green line is the line through the middle of the data. It shows the average trend, yeah, when we see or when we analyze the relationship between X and Y. So we see there's almost no relationship, slight increase, yeah. However, we see what here's a huge constraint. You need to have a high X to achieve a high Y. So yeah, based on regression analysis, we would say, yeah, there's only a slight increase of Y when you increase X. However, from necessity logic, we would say, no, you need to have a high level of X to have a high level of Y. Another feature of Nca is the so-called bottleneck table. The bottleneck table is nothing different or represents the tabular is a tabular representation of the ceiling line. Yeah, the first column is usually the outcome. The next columns are the conditions. So if you have multiple conditions, you have a table with one column on the left, which is your outcome, and the next columns are your conditions. And that is especially useful if you have multiple necessary conditions, because you can look for a certain level of the outcome, which are the necessary conditions what you need to achieve a given value of the outcome. Yeah, the bottleneck table can always be read as, for given value of the outcome, what are the necessary levels, minimum required levels of the conditions. You can use percentage, actual values, or percentiles. Here's an example for our fictive data. Yeah, so you see here I used the percentage range and the actual value, and we see that for a rather low level of y, x is not necessary. Yeah, we do not need have, or x is in the lowest level. However, if we further go up on y, we see that certain levels of x are necessary, and quickly you need to have very high levels of x to achieve high levels of y. Okay. Yeah, key parameters of Nca. Every methodology has specific parameters, and in Nca we use the effect size and accuracy. The focus is on the effect size. The effect size indicates the extent to which y is constrained by x. Yeah, the higher d, the more y is constrained by x. And the effect size is simply calculated by dividing the ceiling zone, which is the empty zone in the upper left corner here, by the total zone, the scope. Yeah, and so by definition, the d ranges between 0 and 1. We have also the accuracy, which gives us the percentage of observations on or below the ceiling line. By definition, for the ceiling envelopment line, which uses the upper left points here, the accuracy is always 100%. Yeah? For the ceiling regression line, there are potential cases above the ceiling line, so the accuracy is lower than 100%. Yeah, and you also see that D depends on the ceiling line that you're using. Yeah, with ceiling envelopment makes the empty space largest. Yeah, the empty space with the ceiling envelopment is larger than for the ceiling regression. Yeah, because it uses the step function, and therefore the effect size for the ceiling envelopment will always be larger than for the ceiling regression line. So how can you interpret these effect sizes? Already in his initial paper in 2016, Jan proposed some arbitrary benchmarks, but these, as always, if you propose benchmarks, researchers will use them, and so these benchmarks are currently established. A D lower than 0.1 is called small effect. Between 0.1 and 0.3 is medium effect. Between 0.3 and 0.5 is large effect, and beyond 0.5 is a very large effect. What you see here, these categories were built on using many studies or samples, and are built on how likely it is to find a really large effect. Currently, we recommend the use an effect size of D larger than 0.1 as a threshold for practical significance. In the past, many researchers have used this threshold in order to accept their necessity hypothesis. However, beyond this practical significance, you should always analyze the statistical significance, because your estimated effect size might be due to or might be a result of randomness, and therefore a statistical significance test was also implemented in Nca, and this statistical significance test gives you a p-value, and if the p-value is small enough, you can conclude that your observed effect size is not due to randomness. Yeah. So at the end, how should you decide about the support of a necessary condition? You would say, yeah, there are 3 necessary but not sufficient conditions for deciding that an empty space indeed represents a necessary condition. First, you need to have theoretical support. Yeah, you always need to think why X is really indeed necessary. Why X is a necessary condition for Y. Why X cannot be compensated by other factors. And more from a statistical perspective, you need to have practical significance. You would say D should at least be 0.1, and you should need to decide about a statistical significance. Yeah, for example, we usually apply the significance level of 5%, where we say, okay, this is statistically significant. So limitations, or
maybe
Nicole, please.
Yeah, maybe here's a good point to jump in, because there are a few questions coming in. And I think one of the questions is worth consideration here in the bigger audience. One of the participants is struggling with the question whether a moderating effect is not the same thing than analyzing a necessary condition. And I can so much follow this argument, because I was in the same thinking for, I would say, 2 or 3 weeks. And I had a few discussions with Sven on that, and I was always convinced that it's not true what he's telling me until we try to look at the formula. I have already provided a text in the chat from a working paper on the misunderstandings on Nca that could be helpful, but maybe Sven, you can give it a try. I know that you have given it a try with me a lot of times, and at some point it worked. So that could be helpful maybe.
Okay, I will go back here because I hopefully, which is the best way to explain it. So what do we see here is the regression line, and what does moderation do? Moderation decides this, if this, or looks for the question behind moderation is whether the effect of X on Y is dependent on another variable. So, but what moderation does, it only shifts this regression line or changes the slope of the regression line. Yeah, but moderation does not give you insights about the ceiling. Yeah, moderation only looks if the slope, yeah, of this relationship between X and Y is dependent on another variable, and that is not, it has nothing to do with necessary condition analysis. Yeah, we only look if the average effect from X on Y depends on another variable. Yeah, but here we analyze not the relationship between X and Y and a third variable. We want to know if X is indeed necessary for Y. So we do not consider a third variable. On the contrary, as I said earlier, yeah, we have one X and one Y, and we are focused on this kind of relationship. Okay.
Sven, I remember that you have, I think in one of your papers, you have even addressed that in a small paragraph. I'm not sure which paper it was, but I remember that there was even the formula given and some more analytical assessment of this difference between Nca and moderation. Wasn't that in one of the publications that I could maybe recommend as a reading?
The earlier publications, what I recommended for further reading about the relevance of Nca, where we have addressed this. This paper was published online, I think 2 years ago. And 2 years ago, we had to struggle with reviewers, because from reviewers, we got the same questions. Yeah, but it's just moderation. And we said, no, it's not moderation. And therefore, we addressed this issue in this paper also. And so please have a look at this paper again, what I was mentioning earlier. We addressed this where someone is drawing on my presentation. Okay, Nicole, do we have further questions?
Thank you. I think that's what was relevant.
Yeah, but it's really an important question. It's important also to understand necessity thinking, or how necessary condition analysis is working.
I mean, there's another one coming in terms of when we have to use Nca. So is there a situation when we have to use it? So it's still a little bit unclear when actually we will go for a necessary condition analysis.
Still talking about fit. Yeah, we had this table at the beginning. I think you, from a theoretical perspective, yeah, start from your theory. Yeah, if you think that a certain condition can block your outcome, yeah, if you think that a certain condition, if it is absent, yeah, and the absence lead to guaranteed failure, you need to start thinking about necessary condition analysis. Yeah, if you want to, I think also in the second part, Nicole, she will also, when we combine PLS and Nca, we will see a little bit the difference. Yeah, usually we assume that X is able to increase in outcome. Yeah, we usually think, how can we increase the desired outcome? Yeah, and we look for things that can increase an outcome we want to have. But that is not the thinking of necessity. Necessity thinking is, what do I need to have to make the outcome real? Yeah, it's about the absence of the outcome, and that is, yeah, it is really important to understand this difference. Yeah, and if you're thinking about the latter, if you're thinking about which conditions need to be there, yeah, to have a certain level of the outcome, or to have even an outcome, you need to start thinking about using Nca. That was the kind of fit I was talking at the beginning. Okay. I see in the chat, I also have a practical example, and maybe this also helps to understand these issues. Okay. Okay, let's continue. Limitations of Nca. I think it is important to say that Nca uses observational data, and like any other analysis technique, cannot guarantee causality. Yeah, so the requirements for causal interference are the same as for any other type of cause-effect relationships. Yeah, the cause should precede the outcome, the cause is related to outcome, and no other variables responsible for the observed relationship.
You in the bandy.
Yes. Very important. From this perspective, it is very important that the identified necessary conditions are theoretically justified. I again see some drawings on my presentation. I'm not sure if everyone else is seeing these drawings. No. Yes, you are all. I'm not doing that. So yes, someone else is. Someone else is doing that. Maybe if it's not too much. Okay. Can someone remove?
I think there's the option to clean and all the drawings.
Yes, yes, okay. Thank you. Okay, again, causality, I think an important issue. And a second issue I think it is important to talk about is that Nca may be more susceptible for sampling and measurement error. It is very important using Nca to carefully consider the empirical design and to check the data prior to its analysis, so to check for outliers. So as I said, I think this is an important issue. So please allow me some more basic insights on this. So why is this the case? Yeah, why is Nca sensitive to outliers? Yeah, simply because only a few cases in the empty space determine the ceiling line. Yeah, let me go back to such a scatter plot here. So yeah, here we say we have strong necessary condition. Yeah, X is indeed constraining Y. So if I put one observation only here, yeah, the whole analysis would look different because the ceiling line, yeah, would look something like that. Yeah, it would go up immediately, maybe go here. Yeah, and so only one or few cases in the empty space yeah, are responsible for this ceiling line. So, but the question is, are few cases enough to reject the hypothesis? And here we have two different views. In a deterministic view, we would say, okay, yeah, every single case can falsify a necessity theory. So this implies that the necessity applies to practically each single case in the domain. Yeah, you assume that I don't know, an engine and wheels are necessary conditions that a car can drive, but you find a car that does not have any wheels, and so our hypothesis is rejected. So someone constructed a car without wheels and it still can drive. So necessity theory or necessity hypothesis is rejected. However, we could also take a probabilistic view. Yeah, a few cases can show up, or in this probabilistic view, a few cases can show up above the ceiling line, such that the empty space is not fully empty. So using this probabilistic view, yeah, necessity statements are more flexible in terms of like practically, virtually, or almost always necessary. Yeah, there is no general rule. Yeah, what are few cases? It is one. Is it 1% of all your observations? Is it 5%? Yeah, these are just arbitrary choices. Yeah, we do not have a general rule on that. So, but you could think about it. And to illustrate it, I have an example here. So this is data from students who applied for admission to a sociology graduate program in the US. The students' quantitative graduate record examination score, this GRE score, yeah, students needed to have a score of at least 620 to be administered to the program. Yeah, so this is a necessary but not sufficient condition. You see, even though multiple students had a score of 620, not all of them got into the program.
I don't know.
Yeah, only 34 got into the program and many did not. Yeah, so students usually have to apply, make a letter, a motivation letter. Yeah, and there are multiple information. So the GRE score, yeah, is not the only condition to be administered to the program. So here we see one case. Yeah, if you remember my my first presentation with the dots, yeah, we said, okay, the presence of X is necessary for the presence of Y, and here we need to have an empty space. So now we don't have an empty space here. Yeah, and the question is, yeah, still, do we reject our necessity hypothesis that the GRE score is a necessary determinant for the admission, or do we have a more probabilistic view? Yeah, in a deterministic view, we would say no. There's no necessity, yeah, because we have one student who got admitted to the program, even if he or she had a lower GRE score, yeah. But from this case, yeah, we know that this person here was admitted based on a faculty member's explicit testimony, yeah. So this person knew someone in the program and was administered to the program, even with a lower GRE score. So in a more probabilistic view, we would say, no, almost always you need to have a high GRE score of at least 620. Yeah, this is the probabilistic view. And I hopefully this example shows you the difference, yeah, when we should think about deterministic or probabilistic view. Importantly, you need to do an outlier analysis when you apply NCA. Usually it is recommended prior to every analysis, yeah, but from my experience, many researchers don't do it. So here's just a path diagram how you should do it. And of course, if you have an outlier due to sampling or measurement error, we would say, yeah, just get rid of the case. Yeah, but if you cannot establish any sampling or measurement error, I would always say keep the case and look at the specific characteristics of the case. What makes the case so important and so interesting? From my perspective, outliers can help you to build theory, refine your theory. Yeah, these cases are important, no? To establish or extend your theory. So be very careful how to deal with outliers. Okay. Okay. We're just kind of conducting NCA. Before I go to my example, Nicole, for the questions, I'm sure.
Yeah, there are a few questions. Some of them we can deal with in the chat. One of the participants has a very specific question where I'm not fully sure whether I get the meaning of it. It's Felix. Felix, if you feel confident to come in, I think that would be the easiest.
Thank you very much. My question is, in the previous slide, we were having both the matrix, that is the quadrant. It was very similar to the confusion matrix where we have the recall and that is the sensitivity and the sensitivity and the other metrics like F1 score, accuracy for determining the whether the hypothesis is true or not. So can we use the same type of true positives and true negatives to identify the accuracy, whether if we have a case where we there is there is some observations in the in the space, that is the no space. I hope I'm clear.
Yeah, I think I got it. You're referring, can we use accuracy, yeah, to establish or to make some assumption about the deterministic or the probabilistic view? I would say no. So from my first reaction would be, yeah, I'm going back again to the scatter plot, because for me the scatter plot always helps to establish kind of this necessity thinking. So if you have an outlier here, yeah, let's assume the scatter plot remains the same, but we have one more case with 2 and of x2 and y8, yeah. So we would have one observation here, yeah, and the ceiling line would be completely different, yeah, because the ceiling line would go up here, yeah, go all the way up and here, yeah. So and the effect size would dramatically decrease, yeah, because the empty space is very low with an observation here, yeah. However, the other observations remain the same. The accuracy for the ceiling envelopment would still be 100%, yeah. However, also the ceiling regression line would look very different because it uses the extreme cases of the ceiling envelopment line. And therefore, maybe only this one case shows up above the ceiling line. So the accuracy would still be maybe the same or similar like that. So whether it's not, so accuracy is not a good measure to decide about the deterministic or the probabilistic view. Yeah. My suggestion would be have a close look at your data, have a close look at the distribution of your data, maybe do different analysis, do analysis with the outlier and without the outlier and compare the results, yeah, and therefore try to learn what is happening with your data. Maybe this single case might be very interesting because the single case is able to reach a very high level of the outcome with a minimum of input, yeah, and therefore it might be a best case in your whole study. So it's really important to analyze these exceptional cases. Yeah. Okay, I hope this helps a bit.
Thank you. Thank you very much.
There is another question on the practical relevance of Nca. So there are some participants wondering whether Nca actually has relevance for business practice projects. I would like to comment on that directly, maybe here, because I have been using Nca for many business practice projects. We are doing a lot of consulting on web shop satisfaction, where we are looking at what are really the drivers of online shop satisfaction in these shops. What do the designers need to think about to make the shop convincing? And in these projects, we very often have also used necessary condition analysis to identify what are the minimum necessary levels for some of these features that need to be there to ensure that there will be online shop satisfaction at the end of the day. These things concern, for example, aspects such as security of your data. These results often indicate payment methods as relevant necessary conditions to some extent. So I would say definitely from my experience in business practice projects, very useful. Sven has introduced the Moscow method earlier. So I think especially for business practice projects, it's quite a nice tool that can be used. So practical relevance, definitely.
Just to add a personal thought on that. Have you looked at how social science have established or have developed in the last years? From my perspective, we are trying to have more and more complex models. So model complexity have increased rapidly in the last years. So because we are more familiar with all the factors that are influencing a desired outcome. So our models include, I don't know, 10 independent variables, 20 and a lot of control variables. So model complexity is increasing over the last decades. However, you have many variables in these complex models, and every variable can explain a slight increase in the outcome. So if you're honest, at the end, you have explained variance of 20%, 30%, which is in my field, human resource management, yeah, because for example, well-being or organizational performance are influenced by many, many other factors apart from human resource management. So the explained variance is not very high. However, we use multiple independent variables, have very complex models. And if you go with such models to practitioners, you say, yeah, I have identified 20 factors that are important to increase your outcome. I think many practitioners will say, yeah, but I cannot influence all 20 factors at the same time. Give me the most important. What are the most important factors that I have success? And from my thinking, or from my perspective, necessity thinking or necessity theory, using NCA can help you to identify with most important factors. And therefore, I think necessary condition analysis is of very high practical value because we can identify the must-have factors.
There are a few questions coming in, but I think that these might resolve when we get to the part of combining the two methods. So in light of the time, I would propose that maybe Sven continues with the example, and then we can see if the questions resolve and bring them in case not.
Okay, I think also the example we can do quickly. So it's an example. Basically, we were asking if certain personality traits are necessary for sales performance. Yeah, we have salespeople, and the question is, what makes a good salesperson? Yeah, and we can look at personality traits that can either increase sales performance, or we could say, do salespeople need to have certain personality traits to have a high level of sales performance? But this study, which is forthcoming in the Handbook of Research Methods for Marketing Management, where Christian is also an editor. So maybe, hopefully, Christian, summer this year, I don't know. What are our variables? We have sales performance, which is kind of sales ability of salespeople, and we have 4 different personality traits. We have ambition, sociability, interpersonal sensitivity, and learning approach. I think, yeah, we don't need to go into detail. So we have 4 different personality traits, and we can assume or hypothesize that these personality traits are necessary conditions for sales performance. We use data from the Hogan personality inventory. Also, no need to go into detail here. Here are descriptive statistics. So here we already see that ambition and sociability might be personality traits that are somehow related to sales ability or sales performance. And before I go, or before I present you the results from the necessary condition analysis, traditional thinking, yeah, OLS, regression thinking. When we use this thinking, we usually interpret, or using OLS, we usually use sufficiency logic. Yeah, we assume that X is able to produce Y, that X is sufficient, but not necessary for Y. We imply that each of these personality traits is able to increase sales ability. Yeah, but using sufficiency logic, we would not say that you need to have one of these aspects, because, yeah, here's the regression formula for the regression analysis. Yeah, if you do not have ambition, yeah, you can compensate the missing ambition through a high level of sociability or a high level of interpersonal sensitivity or learning approach. Yeah, and so for the rest of these other personality traits. So that is our usual thinking. Yeah, you can increase sales ability by a higher level of ambition on average. Yeah, that is what I was thinking. So if you do a multiple regression analysis with these data, we see only sociability. Yeah, we have hypothesized that all four of these personality traits can increase sales ability, but we see from our regression analysis only sociability has a significant effect. Okay, we could decide about the p-value, maybe 10%. It's a small data set, But let's skip to the idea that, okay, we are rigorous and we say, no, our results need to be significant on the 5% level. So only sociability, only for sociability, we find a significant effect. What would be our conclusion? How would we go to practitioners? How would we interpret these findings? In our discussion, we would say, even though we hypothesized a relationship between all 4 personality traits, we only found that sociability has a significant effect. And in our implication section, we would say, please, HR managers, whoever, you have to focus on sociability, right? That would be the implication from the study. And our implication would be a higher level of sociability can increase sales performance. For all the other factors, we do not see a significant relationship on average. So we would assume these are not important. Causal theory or applying necessity thinking is different. So here we would again make our hypothesis, but we would not make a plus, assuming that all these personality traits are able to increase sales ability, but we would say all these personality traits are necessary conditions for sales ability, which would imply that we need to have a certain level of these personality traits to have a certain level of sales ability. Here are the results, the bottleneck tables and the scatter plots, and you immediately see that for low levels of sales performance, which goes from 0 to 5.5 here, all these personality traits are not necessary. For example, for level of 2, you do not need to have a certain level of ambition, and so on. Each of these personality traits is not necessary for a sales performance of 2. However, we see that for level of 3, you need to have at least a low level of ambition. And we can continue this for a level of 4. We need to have at least a certain level of each of these personality traits. And for a very high level of sales performance, which is the highest observed level here in this data set, we see that ambition should be rather high. We need a medium level of interpersonal sensitivity, a rather high learning approach, and a very high level of sociability to have the highest level of sales performance. We can also use this, maybe it also makes it more illustrative when we pick one case in our data set. So we have one specific person, and this specific person in red, you see the actual sales performance and the actual values on this personality inventory. So we will see, okay, the sales performance is 4, and which is possible since this person always has higher levels of these personality traits when it is required. So for ambition, for example, you need to have a level of 33 to have sales performance of 4, and this specific person has a level of 65. So that's okay, and all the others are also okay. So maybe you're an HR manager and you want to increase the performance of this salesperson. You'd say, okay, I want to have a sales performance of 5. So where do I need to start? And here we see, okay, ambition, it's okay. We do not need to invest in ambition. Likewise, interpersonal sensitivity, it's also okay. Learning approach, okay. But we see, here's the bottleneck. This person does not have enough sociability, and therefore this person cannot have a high level or a level of 5 on sales performance. And so we can identify the bottleneck, and we can say, need to invest in the sociability of this person. Investments in all these other personality characteristics, investments in ambition, for example, does not serve anything. It's useless because you need to get rid of the bottleneck first. You need to start here because here's the bottleneck. You need to invest in sociability. Investments in all the other personality characteristics does not serve anything. You need to get rid of the bottleneck. As I said, what's with omitted variable bias, I think is an important issue also because we talked about the model complexity and parsimonies theory when you apply necessity thinking. So here you see the D values for personality traits. You again see the coefficients from regression analysis. So what happens if I exclude one of the variables from my analysis? If I exclude sociability, I do not integrate sociability in my analysis. Yeah, the model for regression is different because we did not integrate important personality characteristics. Yeah, so we see, for example, if I go back and forth, you see ambition. The value for ambition increases, yeah, because we do not control for sociability, and ambition and sociability might be related. Yeah, all the other values are also changing, but what does not change? The values from necessary condition analysis, because it is a bivariate analysis. Yeah, excluding or including sociability is does not change anything for our results. The values are always the same. Independent whether I control for sociability or include sociability in my analysis or not. Okay, does that make sense? Okay, last slides for the first part. Strengths of Nca. If you're thinking about Nca, I think one strength is the newness of the methodology. Yeah, editors, journals, we like new things, right? And if you come up with a new methodology, new thinking, you might have an advantage. And initially I said, yeah, be the pioneer in your field, right? And it could be using Nca could be a good way to get a good publication. Necessity logic, it's a different logic than a logic we are used to. Yeah. And I think that is also a strength. Parsimonious theory, yeah, we do not need to think about all the possible variables, but need to be included in the data. It also makes data collection more simple. We do not need all the control variables. We do not need very complex models. The data analysis is straightforward. It's broadly applicable. Yeah, in any research field, we will have necessary conditions. It's of high practical relevance. I hope this point got clear, and it gives opportunity for very interesting publications from my perspective. Yeah. What are the weaknesses? The newness. I just said it's a strength, but it's also its weakness. Yeah, we know how journals are working and how reviewers are working. So new things will always create skepticism. Yeah, we saw a rapid increase of Nca-related publications. However, it's not a methodology that is really established in the field. Yeah, and so you might get resistance from reviewers, from editors who say, no, it's too new. I'm not sure if it's good or not. So that is kind of a weakness of Nca. It's also non-dominant logic. You have to start thinking about necessity. Yeah, and so also reviewers who are not familiar with this kind of logic might be hesitant to accept your paper. The theory is not about the presence of the outcome. Yeah, we say which level of X do we need, but we do not say how can we increase the outcome. Yeah, but we are used to this logic. How can we increase a desired outcome? Nca does not do that, and therefore combining Nca with other methodologies like PLS is very attractive from my perspective. Yeah. Another weakness, the sensitivity to outliers. Therefore, I got into this a little bit more. Yeah. So you have to think about, you know, and carefully analyze if you have outliers, and if yes, how to deal with it. We have some unresolved technical issues. So what is the best ceiling line? We're still playing a little bit. Also, the inferential statistics are not fully developed. We're trying to establish confidence intervals, for example, but this is not currently at the moment, it's not implemented. Okay, so far for our first part. Maybe time for some questions, Nicole?
Yeah, sure. Sven, there are, of course, a lot of participants who are well trained in the PLS world and who already go through all the evaluation criteria that they have in mind for the typical structural modeling approach. And I think one of the questions goes around this topic of omitted variable bias and also multicollinearity. So again, the question, how are my results impacted by the relationships that might be there between the independent constructs. Maybe you can repeat that one more time to ensure that this is understood, because I will also need that.
Yeah, you need it. And my answer would be, think about omitted variable bias when you think about applying PLS or structural equation modeling in general, or regression analysis. Where's the issue? Where you need to be very careful. In applying NCA, we have the advantage, but we do not need to consider control variables. Yeah, we do not need to integrate them into our analysis. Yeah, and therefore, when you combine different methodologies, when it becomes tricky and when it becomes an issue. Yeah.
So that would be an issue. And then there's another question that circles around reliability and validity of the results, and reliability and validity in the context of NCA. Maybe that is something that we should.
Yeah, I think it's like always, it starts with your data. Yeah. So NCA cannot guarantee you validity, reliability, because it depends how good is your data. How much effort did you put in gathering this data? Yeah, and so NCA just uses, it's just a tool that uses your data and tries to analyze it. And you should think about your measures before you start gathering the data. Yeah, and but again, and maybe Nicole, you're also covering this a bit. Again, combining PLS and NCA gives you an advantage, because using PLS, you have a lot of approach how to test validity, reliability, how to test the quality of your data. Yeah, and if you start with PLS and then afterwards use NCA as an additional or complementing methodology, you already established using PLS that you have good measures. Yeah, but you can be confident with the measures you're using.
So you're not freed up from testing for reliability of the measurements or from the validity of your sample. That is something that you would need to do anyways for your research project, but this is not specific to NCA. So NCA itself does not have a set of specific guidelines or evaluation criteria that you need to go through for the necessary condition analysis. So if we look at the combination of PLS-SEM and NCA in a minute, you have the wonderful situation that you can use all the criteria that you are familiar with in your PLS world, check all of these things. So in terms of the, for example, reliability of the measurements, and then perform the NCA on scores that you generate from PLS. Just checking if we are missing some questions. Oh, I think that is the most, I hope I have not missed one. Sven, maybe you need to go through when we switch roles.
Yeah, okay.
So,
okay, yeah, I would suggest if you do not have any immediate question right at the moment, Nicole and I, we're just switching presentations. So Nicole can, she's going to present the second part. So I stopped sharing my screen. Nicole is starting the presentation from her side, so she can easily flip through her slides. And yeah, we're changing the roles. I'm going to moderate a little bit and have a look at the chat. And I would suggest while we are changing, maybe we have 5 minutes break, or yeah, make a short break really just to switch the slides, get something to drink, have a short break, and in 4 minutes we are starting again.
Fantastic. I hope everybody is back after a very short bio break. And Sven has done a very nice introduction on necessity logic and the idea of necessary condition analysis. And in the second part of the presentation, we would like to focus on the combination of partially square structural equation modeling and necessary condition analysis. When we started this whole necessary condition analysis adventure, I would say a couple of years ago with Jan Dull becoming ambassadors for NCA, we were very enthusiastic about it. And at some point, I started doing some videos on a YouTube channel, publishing that. And then also in the channel, there are a lot of PLS related videos and links. And there were a lot of questions on, can we use Nca with PLS-SEM? Where's the difference? So many of the questions that we have seen earlier today were coming into comments to my videos or posted to my email. And then at some point we decided, let's make a nice project and see how can we actually combine PLS-SEM and necessary condition analysis. It's not something that is of super difficulty, but of course, if no one has done it before, there's a lot of insecurity around this whole process. So we decided in a nice team together with Sandra, Christian, and Marco and Sven to come up with an article where we try to give guidelines on how we could combine PLS-SEM with necessary condition analysis. Please note, as Sven has already indicated, we are still in the process with some of the developments. Jan is playing around with different ceiling lines, so there might be new developments around this new method. But this is kind of the first set of experiences that we wanted to share as a guideline. Yeah, in terms of factor scores or composite concepts, latent concepts that you are used to using in partially square structural equation modeling, yes, these can also be used in necessary condition analysis. The analysis itself doesn't care actually which kind of measurements you introduce to the method. So it's working with everything. And it's your job to ensure that the measurements that you integrate to necessary condition analysis are useful, are reliable, are making sense for your research projects. So you can use factor scores and you can also use composite scores that are generated in partially square structural equation models. When we discussed the question which scores actually to use, we also discussed a little bit in team. We came to the conclusion, yes, if we are going for a structural equation model, and we are interested in certain relationships that are kind of represented in the model, we would recommend using the composite scores of PLS-SEM because they actually represent the underlying theory, the conceptual thinking that is there on the structural relationship between the different constructs that we're using. To make this part a little bit more practical, we decided to refer everything to an illustrative example that we were also using in the article. It's on technology acceptance. You can see that here on the slide, we have two dependent latent constructs, adoption intention. So am I willing to use a certain technology, and technology use, am I actually using the technology? And then in this world of technology acceptance, there are a lot of well-established models that explain what are really the drivers or the determinants of adoption intention and technology use. So we used emotional value, ease of use, usefulness and compatibility as independent or exogenous constructs that explain adoption intention and technology use. Just a few words on that. Emotional value is you are excited about the technology, it's a pleasure using it, that will drive your adoption intention. Ease of use, it's just easy to use, navigation is easy, menus are easy to understand. Usefulness, you think it's actually of use, it gives you an advantage of not using the technology or of using the technology over not using it, and therefore it increases your adoption attention and technology use. And compatibility, it fits to your lifestyle, and that's why a higher compatibility would produce a higher adoption attention and technology use. That is the conceptual model, and we had a very nice data set collected in France from a PhD candidate, Sandra, who was involved in the project. So that was the illustrative case. If we look at this illustrative case, we are usually in this sufficiency logic, and Sven has introduced that right at the beginning of this webinar. So with the sufficiency logic, we have usually a lot of well-established theories that we are going to test. We test relationships here, building on technology acceptance model, theory of consumption values, innovation diffusion theory, that are all talking about these different constructs that are part of our illustrative example. So it was rather easy for us to say, yes, the exogenous constructs are positively associated with the endogenous constructs. We could come up with some hypotheses here, and that would fill up the part that we would need for our partially square structural equation model. Then the question might be, and a lot of you have already asked the question, is it relevant to integrate necessity logic or necessity thinking? This depends, of course, if there is an indication that necessity logic plays a role for your example, for your illustrative case that you're looking at. If there's an indication for necessity logic, so you feel, yes, it could actually be of use to analyze it, the question is, how do we actually integrate this necessity logic into our partially square structure equation model. And to give you some guidelines, we came up with a step-by-step flowchart guideline that goes through the different steps that we would recommend following for this combination of the two methods. You can see the 8 steps here on the slide. The first step, and that's the step in all of your empirical data analysis, I would assume, is the theoretical background and the research hypothesis. You would then go on preparing and checking the data. There are some specifics that we need to look at when applying Nca in combination with PLS-SEM that we will introduce. You can then see in step number 3 and 4, we are pretty much in the PLS world. We run the PLS analysis and we evaluate the measurement models as a typical first steps in your structural equation modeling analysis. We then could transfer the scores that we generate from PLS-SEM over to a necessary condition analysis in R or RStudio. We run the necessary condition analysis to generate our findings on that one. We start evaluating our structural model, and then we can make a combined interpretation of the results that we are generating on necessity and sufficiency logic. And now let's go through the different steps. The first step is the theoretical part. And usually when you look for necessity logic, we said it earlier, it's very seldom that there are already well-established theories on necessities. In many fields, however, we see that a lot of authors are actually talking about necessities. Sven and I have done a couple of reviews in the meantime, one in IB also, where we went through all the different articles and we found a lot of authors who are actually in the theoretical section talk about necessity and have a lot of necessity-related arguments. A necessity-related argument is also to be found in technology acceptance. We have a few authors that found, for example, that compatibility with a lifestyle may represent a necessary but insufficient condition for technology acceptance. Another team of authors assumes that usefulness of the technology is a prerequisite for technology acceptance. So you see again, we have some of the keywords that Sven has presented in one of his slides to identify these necessity logics. This is an indication that they are talking about necessity, and there are also further studies that use, for example, qualitative comparative analysis, indicating some idea of necessity, but there is no well-established theory around technology acceptance yet that talks about necessity. So for our illustrative example, we kept it simple and we just said, okay, let's test it. There is some necessity thinking in the field. Let's just test whether the exogenous constructs are necessary conditions for the endogenous constructs. You can criticize that and say, Nicole, you needed to have done a much better job here in terms of the theorizing. You might be right, but the focus of this illustrative example was more on the guidelines of the combinations. So still we say theory development is a challenge on the one hand side, but on the other hand side also a chance to make a contribution because there are these arguments, but not well-established theories yet. To help you a little bit with the theorizing part, we decided to give you some ideas here on the slide how you could approach that. And I think that is something that we have not so much highlighted in the article, but that is something that we are currently developing a little bit more also in the team of Nca ambassadors. A necessity logic, if you look at this kind of matrix, you have different situations and there are different things that you would need to explain if you go for a theory on necessity. The first thing here is that you need to argue why the absence of a construct, for example, usability, usefulness, causes the absence of the outcome, for example, technology use. So that is the first job that you would need to do to come up with a theoretical mechanism. The second part is that you would demonstrate that in cases where the outcome is present, so where there is technology use, that there is also perceived usefulness, for example. And then the third part, and I think in my projects at least, this was the hardest part, you will need to discuss why there is no substitution. So why is the independent construct's perceived usefulness not substituted by other things to produce the outcome technology use? And that has a lot to do with this kind of bidirectional character of the Nca. Sven has introduced earlier, we do not need control terms. We do not discuss omitted variable bias. So it's really about, in terms of theory, highlighting there are no substitutes. And that could be, I would say, for some of the topics, a challenge. You have to see that for your own field. We have taken this table from a book on multi-method research that is talking about causality, and they are actually providing these kind of recommendations to come up with a causal theory on necessity. I found it quite useful. It's not something that is kind of written in stone. It's just an idea that we would like to present here to give you some guidance. So that would be the first part. You need to think about your theory. The second part is you need to prepare and check the data. And there were already a lot of questions that related to, for example, sampling. The good news is there are no specific requirements that are coming from the method necessary condition analysis to the sample size. You just follow the guidelines which are there in the field. If you are a combination researcher with PLS-SEM, it would be a good idea to just follow all the guidelines that have been outlined in the PLS-SEM context. We had a sample size of 174, but for the necessary condition analysis itself, it would work with fewer cases as well. In terms of data distribution, again, the good news that Nca is not bound to certain distributional characteristics. Again, you can follow what is there in the PLS-SEM context. Nothing else to look for when doing a necessary condition analysis. PLS-SEM, we know that we have the experts here in our webinar, is quite flexible in terms of data distribution. There are some discussions going on that. Of course, you would need to report some skewness information. We have done so in the article, but there's not much of a restriction if we talk about data distribution. In terms of the preparation of the data, one of the steps that I would, from my own experience, feel would be a little bit more relevant than in the PLS world is the detection of outliers. Sven has introduced that if we have a certain outlier that is in this upper left corner in the empty space that we are looking for, we have a problem in terms of identifying necessity. So we need to ensure that this case that might be then the empty space is a true case that is maybe falsifying an idea, or if it is a sampling or measurement error. So that is something that we definitely need to check, and we need to do very careful when applying Nca in combination with PLS-SEM. There are some generic recommendations in the literature. One of the recommendations is to look at the standardized scores above 3 as an indication. So you identify where are the scores that have very seldom combinations, very outlier characteristic-like values, and then you would need to double check, is that a true value or is that coming from any kind of data entry error, measurement error, or sampling error? In terms of measurements, again, Nca is open to any kind of measurement. Sven has introduced these different cases. We even have had these 0-1 cases, that's no problem. From the PLS world, we normally use metric or quasi-metric scales, very often these Likert type scales. And that was the case here too. So we used 5-point Likert scales, for instance, to measure usefulness or adoption intention of the technology. One of the things that is very relevant at the beginning of your project is that you ensure that the coding of your scales fits to Nca. I do not know whether you remember this chart that Sven has introduced earlier, where it's indicating that we have an empty space in the upper left corner here. And the idea of necessary condition analysis is that it has a ceiling line and identifies this empty space. And the Nca that is implemented in RStudio only looks for the empty space in the upper left corner. Theoretically, the corner can be in every kind of region of the diagram, of course, but technically, the software is only looking for this empty space in the upper left corner. That is, you need to ensure that your theoretical coding of your variables will represent this situation where you would need to find the empty space in the upper left corner. To make this 100% clear, one example, we have usefulness as a construct or variable here, where 1 would be a low usefulness, 5 a high usefulness, 1 a low adoption intention, and 5 a high adoption intention. And we would assume that usefulness is necessary for adoption intention or for high adoption intention. And that is, we would look for an empty space in this corner. We would assume that we would need a high usefulness to come to a high adoption intention. So we would assume that we would have an empty space upper left. And that's exactly what we need. And that is something that you would need to ensure at the beginning of your project. Good. If you have done so, fantastic. Next step, you run the PLS-SEM analysis. And we have not integrated specific information on this here because we assume that you are all PLS enthusiasts already. So you run the PLS-SEM algorithm as you would do in any other PLS-SEM project. I have copied in here a guideline from 2019, when to use and how to report the results. That could be of help. Christian can, I do not know, jump in if he has new guidelines that I should refer to, but that is something that you can just follow as standard for any PLS-SEM project. Step number 4, also nothing special. You evaluate the measurement models using PLS-SEM. So you ensure that your measurements are reliable and fulfill all the different quality criteria that you are familiar with from the PLS-SEM world, and can then afterwards use these four in your necessary condition analysis. So actually that's quite a good combination of the two methods, because NCA is not giving specific criteria to check for reliability, and you can use all of these things from the PLS world to do so. So that would be step number 4. In step number 5, there's again where we have the combination of the two methods. You would need to transfer scores from PLS-SEM to your necessary condition analysis. In the PLS-SEM model, you might have constructs that are measured in reflective measurement mode or formative measurement mode. If you have constructs that are measured reflectively, then you would use the latent variable scores from PLS-SEM and transfer these scores to your necessary condition analysis. That is, the necessity is tested on the level of the construct. For formative measurements, if you have an endogenous construct that you're looking at, we would recommend also doing the same thing, using the latent scores from PLS-SEM and put them over to the Nca. So again, you look at how does the necessity impact on a certain outcome latent construct. If you have an exogenous construct that is measured with a formative measurement mode, it might be a good idea to also include the original indicators, 1, 2, 3 is given here on the slide, because then you get additional information on potential necessary levels that might be there on the indicator level. So it's kind of a complement to looking at, or only looking at the latent construct, in addition looking at the indicator levels here to get information where are really the necessities on the level of the construct and on the level of the indicators. As you would do in your PLS-SEM analysis, where you would look at indicator weights and make an interpretation on these weights, you could then complement this by interpreting the necessary conditions on the indicator level here. For our example, you might want to criticize that. It is very simple. We have just used reflective constructs, and we just needed to transport or transfer the latent construct scores from PLS-SEM to Nca. And this is done by exporting these scores to a CSV file, an Excel file, and then importing this Excel file to R. I do not know whether you are very often using the latent variable scores. I could assume that maybe this is not so often used in your typical analysis. If you're using Smart PLS, which I guess is anyways the best software for doing a PLS-SEM model, but maybe also the one that is most popular here in this audience, you have in the output in the PLS algorithm run, you get all the scores for the latent construct that's automatically produced. There's nothing that you have to do in addition. That's kind of an output, which is anyways there in Smart. And you can see, you can copy these things to Excel. I think there's even a copy option to R. We use usually these Excel format to import that later. So that works fantastic.
Nicole, if you might, maybe we can stop here for a second and can explain what are the advantages of using this latent variable scores. So in the chat we have various questions about different or using different scores, and maybe it's good here before we go on with the analysis to explain a little bit or to go a little bit more into detail here why we suggest to use the latent variable scores.
Yeah, sure. I mean, you know that maybe from some of the projects, I do not know which fields you're working in, but maybe let's look at one example. If you are measuring a construct that is typical in social science or or management, you could have something that is loyalty or that is satisfaction. Yeah, so you would like to measure something using a question in a questionnaire. And you, of course, have the option to measure this idea of loyalty or satisfaction with one question, saying, I'm totally satisfied with the service of this company. I agree from 1 to 5, or total satisfaction is 5, no satisfaction is 1. And you measure this with one indicator. Usually when you have constructs that are a little bit more complex, yeah, to measure, you would use multiple indicators to represent these constructs. So very often when we talk about loyalty, for example, there's something like, I would recommend the products to family and friends. I feel attached to the product. I would rebuy it again. So there might be different facets that could all be relevant for this idea of loyalty. And in terms of a latent construct, the advantage is that you can use multiple questions to represent the construct, which makes usually your measurement better. You have better reliability in terms of measuring the construct. And that is a very typical approach in PLS-SEM. Is also reflective versus formative something that we should repeat then, or help me out, Sven, in terms of the questions that are coming in?
No, from my perspective, we had a lot of questions in the chat. It's really good to see how the chat evolves. No, basically, I think the question was more a basic question, not to use reflective formative, but should we use the latent variable scores which are calculated within the structure using PLS and the model, or do we use additive scores, average scores? And so our suggestion would be to use latent variable scores, because these latent variable scores are created within a specific context, namely the model that you are analyzing, and therefore we would suggest to use these latent variable scores, right?
The question is of course fully there. I mean, we also discussed that when we have written the article, and we have even simulated different calculations for the different constructs. We use different algorithms. We use the factor scores. We use kind of mean values for the constructs to see what is really the outcome for the necessary condition analysis. And yes, of course, this will change the result depending on what kind of measurement you are using. And then you can discuss what is the best way to measure the constructs. And I mean, we also discussed that a little bit in team, what is now the best way forward. And we at the end decided, yes, we should use the composite scores from the structural equation model, because when we are interested in modeling these relationships structurally in the model, we have a certain conceptual idea, a certain idea on associations. So we would assume that it's best to use the composite scores coming from this model, because this is then the best thing to complement the structural equation model interpretation. Of course, that can be debated, and you might have reviewers that will challenge you a bit on this question. I mean, as anyways, reviewers are maybe talking about whether formative or reflective is here the best measurement approach for your variables. So that is something that you can discuss yourself. And if you are, I do not know if we have only a PLS-SEM users here, but if you are a user of regression and factor analysis, for example, that could also work. You can also work with a factor score for the model. So it's doable. Yeah. Okay, Sven will stop me if I need to repeat something. Okay, so we have the latent variable scores from PLS-SEM generated in the software, and you can transfer that over to our studio. If we think about implementing the PLS-SEM model into a necessary condition analysis, let's look at our example. We have here our example with two dependent constructs or endogenous constructs, and we would now need to implement these relationships to a necessary condition analysis. As highlighted before, necessary condition analysis does not have this multivariate thinking. I mean, we can use more than one variable in one analysis, but it does not change the results. So what we would need to do here for a necessary condition analysis is 2 Nca, 1 for adoption intention, so 1 for one of the dependent constructs, and 1 for technology use with all the latent scores or constructs that are independent or exogenous construct of relevance. So it's 2 times necessary condition analysis for 1 PLS-SEM model. Now you could say, yeah, Nicole, it's nice. You had all reflective measurements. My model might look more complex than yours. You might have a formative measurement included. What then? Let us simulate that a little bit. Let us assume you would have measured emotional value with a formative measurement construct. Then what would be the implication? The implication would be that you, in addition, integrate the 3 indicators of emotional value to your necessary condition analysis. You can do that in a separate step. You can integrate this into the necessary condition analysis that you are anyways performing. The results do not change no matter how many variables you integrate to the analysis. Is that understandable, or is there already screaming and shouting in the chat? No, Sven's laughing, maybe not. Okay. Running the necessary condition analysis. Now we're talking about it more than an hour and you wonder, okay, how does it actually work? There is a software package for doing so in this statistical software R or RStudio. And Jan Dole, the founding father of Nca, has written a package that you can use in Nca. And the fantastic news is he has also provided a quick start guide that gives you an idea of how to install the software, which kind of codes to use, and so forth. I think one of the sentences in the quick start guide says, do your first necessary condition analysis in less than 15 minutes. When I was first reading it, I thought, yeah, of course, less than 15 minutes for an analysis, I doubt it. I think it was a little bit more, but it was also not considerably more time that I needed for doing so. So it's actually really very easy to do so. I think the most difficult step for me was installing the software. That was the hardest part of it. I have on the next slide copied over example codes that you use in R. So the bad news is, for those of you who are used to Smart PLS, that RStudio is less, I would say, user-friendly. The ease of use is lower for RStudio than for Smart PLS. It's a software that works with codes, so you just type in certain codes or orders, commands for the software to perform a certain analysis. And what you see on this slide is more or less the full code that you would need for our example. So again, it's really very easy to do so. Just to give you some look and feel, this is how the user interface of RStudio looks. You will have here a window or menu where you put in the commands. You get here some of the results, effect sizes, and so forth. You can see here the data set that is imported to RStudio, and you get some of the scatter plots automatically produced on the right-hand side. So the only thing really that you need to do is install this R in RStudio user interface, use the command lines, and you get what you need. Some of you might have worked with R before and say, okay, that's easy. I know how that works. Some of you might say, I have never used it. And that's usually kind of a challenge to start with that. One of the things that I can recommend if you have never used it before is the quick start guide from Jan. And of course, my fantastic YouTube channel that I would like to promote here. You have a playlist on necessary condition analysis where you really have everything in terms of the basics of necessary condition analysis, the software, how to install it, how to import the data into R, how to run your first basic necessary condition analysis, and so forth. In total, the videos add up to 21 minutes, and that's exactly the time, I would say, if everything runs smoothly, that you would need to perform your first NCA. Good, let us assume you have successfully managed to install the software and have run your first necessary condition analysis. And let us see what are really the results for our example. We have here adoption intention and technology use. We have here the different latent constructs that are in our PLS model, the drivers or determinants of the constructs. And we can see here the C, E, F, D, H effect sizes and the corresponding p-values to see if they are significant or not. Now Sven can test whether I was attentive to his explanations. He said something about the relevance and significance of the effect sizes should be above 0.1 to be practically relevant, and it should be a significance of 5%. Fantastic. If you go through all of these numbers, you will figure out we almost have, for all of our constructs, necessities involved in the model. For compatibility and adoption attention, we can discuss it's significant, but it's below 0.1. So that's kind of a borderline thing. If we fully follow Sven's guideline, we would say, yeah, okay, it might be statistically significant, maybe not so practically relevant. So that is the good news. We have a lot of necessity in our model. That's why it is a fantastic illustrative example. Let us pick two values to get a better understanding of the meaning of these things. Let us look at usefulness, having an effect size of 0.119, statistically significant, and compatibility, having an effect size of 0.211, also statistically significant for technology use. And I have here just copied over the two scatter plots for these two things, usefulness and compatibility, here on adoption intention, here on technology use, to give you a feeling, a look and feel for what does this effect size number mean in the scatter plot. And we have introduced it earlier as always about this empty zone, this empty space that we are looking for in the scatter plot, and where we can very nicely see that we have quite a large empty space here in comparison to this empty space, which is then also reflected in these two numbers of the effect size, which is the same thing. The calculation is done on this graphical area that we can see in the scatter plot. Another thing that we get from our necessary condition analysis is the bottleneck tables. Sven has illustrated this nicely with the sales example earlier. So we have a bottleneck table here for adoption intention, and this one is given in percentage ranges. Basically, you can adapt the way you want to see the bottleneck table as you want it. I have one example later. Here we have adoption intention in percentage ranges from 0 to 100. That can be quite intuitive. So what do we need to do to achieve 70% of adoption intention, for example? What are the minimum levels of our independent or exogenous constructs to achieve adoption intention at a level of 70%? Let us look at our example of usefulness, just to pick one here. We would need 15.7%, or let's say 16% of usefulness to achieve an adoption intention of 70% in our model. So we really have an indication on what are the minimum required levels to achieve a certain outcome here, adoption intention. The same, of course, for technology use, the same procedure. What do we need to achieve a level of technology use of 70%? An example, we would need 33.7% of compatibility or 34% to achieve 70% of technology use. And coming back to the question earlier, this is practically highly relevant information, of course, to get to know, okay, what do I need to achieve to make my technology used? We are currently doing a consulting project for a small company offering HR software, and they are exactly interested in these levels. What do we need to perform, or what are the levels we need to achieve to make our potential users, small and medium-sized firms, adopt our software? I tried to highlight this earlier. You can ask for bottleneck table representations in any way you want. When we look at the scatter plot, we usually have the original data levels from PLS, which is using standardized scores. We can see the representation of the ceiling line here, and you can actually have a bottleneck table on these actual scores. So you can ask for actual numbers in the bottleneck. You can also ask for a certain number of steps that you would like to see in the bottleneck. The default usually is 10 or 11, so from 0 to 100, but it's on you to design that or customize it the way you want it. And we have done a couple of projects where we combine PLS and Nca, and usually one of the challenges from my perspective is that we have these standardized scores. So the latent variable scores are standardized, and maybe it's nice either to go for the percentage ranges. If the reviewers don't like it, you might have the exercise of recalculating the standardized scores back to the original scales, if that is a possibility, to ease interpretation later. But all of that is possible. It's just a bit of extra work on your side. And what is nice, I would say, in this representation, you can see that the bottleneck is nothing else than the ceiling, the stepwise ceiling line in this case, as a tabular format. Yeah, it's the same information. Good. Next step, we have now run the Nca. Fantastic. We have generated some results. Next step, we are in the combination use. We would evaluate our structural model. That is, we have anyways performed the PLS-SEM, and we have generated some nice model results. And I have just brought the findings from our illustrative example here. So we can see technology use and adoption attention. We have an R-square. Let's comment on that in a few minutes. And we have our path coefficients indicating how relevant is, for example, an emotional value or usefulness for adoption intention and technology use. Meaning, if we have a higher emotional value, we will have a higher adoption intention. If we have a higher usefulness, we will have a higher adoption intention. So that is our typical sufficiency logic interpretation of results that we are familiar with. R-square, I think that was something that I've seen in the chat before I took over from Sven. R-square is produced in Smart PLS, telling you what is the explanatory power or how much of the variance in adoption intention or technology use is actually explained by the constructs in our model. The concept of R-square is not present in necessary condition analysis. So the idea of necessary condition analysis is not about explaining variance or something. So there is no R-square, which is a little bit of, a strange feeling for people who have worked for 10 years with R-square values. I can get that. But that is something that you get from your Smart PLS model anyways. So now what do we have? If you remember the results from the Nca, we found a lot of necessities. So we have almost all constructs being necessary conditions for the outcome. From the PLS model, we see that actually two constructs are significant determinants or drivers of adoption intention, and one is a significant driver of technology use. So we have the situation where some of the constructs are significant drivers and necessary conditions. We have a situation where some things are non-significant drivers but necessary conditions. And there could theoretically be a situation where we have a significant driver but no necessary condition, which is not part of our example. And I do not know if this already triggers what is going on in my mind, at least. That's quite an interesting complementary information that we now have the two perspectives combined. We have information on necessity and sufficiency, and we can talk about what are the minimum levels and where are the things where I can invest a little bit more to get a little bit higher outcome on top. I have just copied over here the results in the typical tabular format. We do not need to go through all of that. One of the things that I would like to highlight is that in PLS-SEM, we might, of course, also have something such as a total effect. Let us look at emotional value being a significant determinant for adoption intention, being again a significant determinant on technology use. That is, in our example, we have a total effect from emotional value to technology use. That is here in our example actually significant. Yeah, so we have kind of a two-step mechanism. These things are not integrated in necessary condition analysis. So there is no two-step Nca at this point in time. So that's a little bit a challenge where you have to be creative and think about what to do with it. We are not yet at the final stage of knowing what is the best way of interpreting things, but just to keep that in mind, figure out, yes, there are some significant total effects. What does it mean for the model, and how do we compare that to necessity? Let us look at the example. We have introduced 3 different scenarios a few minutes ago. Significant determinant and necessary condition scenario number 1. Significant determinant but no necessary condition scenario number 2. And non-significant determinant but a necessary condition as scenario number 3. And we can then say, where are our constructs actually located? And let us use 2 examples. We would have usefulness and compatibility. Usefulness being a significant determinant. Yes, it is significantly related to adoption intention and a necessary condition. And compatibility on technology use is non-significant for technology use, but a necessary condition. And then we had the situation that we just introduced, what to do with these indirect total effects. We have emotional value that is not a direct significant determinant, but has a significant total effect on technology use. So we might put it in this box, but that's at the moment kind of up to you. What does this mean if we now have these different scenarios? Let us look at the 2 examples, usefulness and compatibility. Let us use scenario 1 for usefulness. We have seen earlier that there were authors saying, yes, usefulness is a prerequisite for technology acceptance. And we can say, yes, usefulness is a prerequisite for technology adoption intention. A certain level of usefulness is necessary to create intention to adopt a certain technology. And we can even specify this level that we would need from the bottleneck. That is, for a high adoption intention of 70%, we would need a perceived usefulness of 16% in our situation. So far, the necessary condition analysis, plus what do we know from PLS-SEM? A further increase of the perceived usefulness is recommended from a management perspective, as it will increase the adoption intention even further. So we really have the situation, yes, there is a minimum level that we need, plus if we increase the independent or exogenous construct further, we have the ability to also increase the outcome further. That would be scenario number 1, and that is a very nice complement in the PLS-SEM. Scenario number 3 is a situation where we have, we look at compatibility. We find, yes, compatibility is again a necessary condition for technology acceptance, namely for technology use. And we can specify this necessity level again from the bottleneck table. We know for a high technology use of 70%, we need perceived compatibility of 34%. And in this situation, compatibility is a non-significant construct in PLS-SEM. That is, a further increase is not recommended, as it will not increase the outcome further. And that is, I would say, where you immediately see that there's a nice value in combining the 2 methods, because you get these additional insights from these 2 perspectives. Highly practically relevant and very nice to increase or improve theory building in many fields. These are 2 examples. In the article, we also offer kind of an interpretation guideline for 3 different scenarios. Scenario 1 and scenario 3 are the ones that we've just seen in the example. There might be a second scenario where we have a significant determinant but no necessary condition. And there you will have your typical interpretation. An increase in the exogenous construct will increase the outcome on average. And there is no minimum level that we need to ensure for the outcome to exist. Yeah, in practical projects, there's a lot of, I would say, challenge going around these bottleneck tables and the way of interpreting things, in addition to these more generic findings that are maybe specific to the fields. One of our recent articles where we also blended the use of PLS-SEM with Nca is offering a further interpretation grid that helps you interpret findings from bottleneck tables. So that could be a recommended article, although it is, of course, on a very specific topic here. Yeah, that was what I wanted to introduce on the combined use. I do not know, Sven, how's the situation in the chat?
Quite. No, on the contrary, we have several questions which we try to address also in the chat. But I think we should also address some more general questions. The first one is, Nicole, you nicely explained how PLS and Nca and the results can provide additional insights, can provide or address different perspectives. One question that came up is, does Nca helps us to identify which are the mediators or which are moderators in our model? Do you want to go ahead on that?
That is a fantastic question, because at the beginning of the project, we thought that we would integrate a full section on mediation and how we would need to implement a mediation relationship or different forms of mediation in a necessary condition analysis. I must admit, we kind of gave up for the article because we are not yet there to fully say what would be really the best guideline to implement a mediating relationship or moderating relationship from PLS in the necessary condition analysis. So you see, there is still some room for us to work on guidelines and to see what are actually best practices on these topics. So it's not yet there. I think Jan is discussing a mediation chain in his book on necessities, where you look at if A is a necessary condition for B and then B is a necessary condition for C, we have something that he would call a mediation chain of necessities. Yeah, but it's still not yet fully developed, I would say, the forethinking. If you think of PLS-SEM giving very concrete guidelines on what is a complementary mediation or a competitive mediation or full mediation, that is something that we have not yet developed in the Nca. So it's still a little bit a trial and error, I would say, for mediation. And in terms of moderation, of course, what you could do if you have a moderator, you could test if the moderating influence is necessary for something. But I must admit, this is already then quite tricky in terms of the theoretical thinking, what this actually means as a result if you find that a moderating term is necessary for an outcome. So we have not yet fully thought it through. That's at least my perspective. Maybe Sven has. But
no, and what's an interesting thing about necessity and applying Nca, it still gives much room for new thinking, and we are also learning. Maybe just two thoughts. One for the mediation analysis. Still, it's about theory. Yeah, so we I continue now. Theory. What Nicole mentioned is necessity chains. Yeah, so if you have a mediator and you think about a chain where the mediator is, or you have one X, which is necessary for the mediator, and the mediator is necessary for Y, this is a different thinking. Yeah, so instead of trying to analyze if X and Y, how the relationship, the average relationship, yeah, between X and Y depends on the mediator, can we explain the average relationship with the mediator? Nca does something different. Yeah, Nca does analyze, do you need to have a certain level for the mediator, and again, do you need to have a certain level of the mediator for the outcome? Yeah, and for moderation, still, as Nicole said, it's a tricky question. So if you think about moderation in terms of different relationships between different groups of your analysis, for example, gender. So you could think, yeah, maybe we have a gender moderates our relationships. If you think about moderation in necessity thinking, you need to consider that what you do, you still have your bivariate analysis, and if you separate your analysis for male and female, you will reduce the cases you have. So the scatter plot for male and female will look different. So the ceiling lines for male and female will be different. And probably what will happen is that the necessity will increase because you have fewer cases. Yeah, just one thought on that.
I mean, that's quite tricky. As Sven said, we had one project where we're looking at different factors from the HR perspective, and we had data for different countries. And then we found that in some countries, a certain practice is a necessary condition, whereas it is not in other countries. And I thought, okay, maybe it's not a big problem. We can use it as an exercise and simulate that a little bit. And then Jan said, yeah, actually, it could be a problem because of the theory that would then indicate that it's not really a necessary condition in a very strict sense. Because in the necessity thinking, the idea is that there are no substitute. It must be there for the outcome to exist or to manifest. And here we then would talk about a contextualization. And yeah, that's part of the theorizing, which is not yet fully developed. So that makes it a little bit tricky in practical projects. So at the moment, we kind of refrain from integrating an example on moderator and mediation for a certain reason. You can see, you got us here for our illustrative case.
Okay, can I add one thought, because I see another question in the chat. So can Nca represent causality? I had a slide on that. And I think we also had earlier a question about causal interference. And no, Nca cannot guarantee causality. I try to explain it. So again, yeah, if we want to have or establish causality, yeah, the cause needs to precede the outcome, etc. So Nca is no guarantee for that. So it depends on the data, it depends on the analysis, and Nca is no guarantee for causality. Okay, maybe, yeah.
I have a few slides that should give you some guidance, and I can see we're almost already done with the time also, which is good that I come to the end. So we have a few slides that provide you with information and potential sources of support to follow up on your own Nca and PLS-SEM projects. There's a website that is specifically targeting the Nca community that is at the University of Rotterdam, Erasmus University of Rotterdam. You can see the link to the website here. It's providing all information on Nca, on publications. There's a calculator on the website for a quick and dirty Nca that you can perform. But actually, as it is really very easy to do that in R, I would say, yeah, calculator might be nice, but go for the R package and do your own Nca. That's really fairly easy. Here we have the link to the quick start guide that we were talking about that is also available on the website. I have promoted my YouTube channel already. I will do that here once more. It's a good channel to look and understand Nca. There are some social media sites. Sven and I are not so active in the social media otherwise, but Jan in Rotterdam is, and of course Christian is as well. So Christian, I think, will link all of these information for the PLS community, plus you will have the relevant social media sites from the Nca community here. Yeah, we have a few slides that's in the slideshow just for you, for the website, the calculator, the software R. We have introduced that. You have seen the quick start guide. I do not need to repeat that. I have promoted my channel. That is obviously how Facebook looks from Nca. Let me just highlight two more things before we can open up for more Q&A. There are two upcoming webinars or offers. One is an Nca webinar that we are offering in Odense at the University of Southern Denmark. It's a 2-hour webinar. It's pretty much, I would say, relevant for those people who have not been here today, but still have an interest to get an introduction to Nca. So maybe not for you, but for your fellow colleagues. Again, offering a foundation, you have the relevant links on the event and on the registration. It's for free, so feel free to join. In addition, there is a summer course. So this is a full week course held in June and offered by Jan Duhl and I think some of his team members. It is even providing one ECTS. I think if there are some of you who still need to collect some ECTS points for whatever reason, you have more information via this link and you can register here. And I think that this course is actually not for free. I think it was about 250 euros as a fee that you would have to pay for participating in here. Yeah, let's jump into Q&A, open up for discussions. I mean, we have in between already tried to answer some, but maybe there are further questions. And I think I will stop the slideshow, then I can see you better and also follow what is going on in the chat.
Yeah, Thank you, Nicole. And I would also say, please feel free to raise your questions. We have tried to keep track of the chat. Nicole in the first part and many others, Christian, Marco, Wangu, many people were engaged. However, I'm sure we missed some questions. And if you please feel free to raise these questions. If not, I would always offer, yeah, we are all people engaged and interested in moving also forward, and your questions can also help us. So feel free to also contact us afterwards regarding NCA, regarding PLS, but Christian, Marco is just going on here.
Okay, I think before we go into the Q&A, I should switch the video recording off, right? So people might be afraid to ask questions, so I stop the video here. And okay. Just to finish the official part, let's say thank you very much. This was Prelude PLS2022 Prelude session number 2. And we are definitely going ahead with a series of presentations coming ahead of the PLS2022 conference in Beijing, and this is certainly something I like to promote here. And if you like further information on the next Prelude sessions, we will definitely post it on the PLS2022 webpage. So that is for now. Thank you very much, and I switch the video off here, the recording.